Assalamualaikum and selamat sejahtera. Okay, so this is chapter 2, content chapter 2 for FSM. Now we go to Mealy model, second model of FSM. Okay, this is the topic outline. It's like more machine also. We have state diagram for Mealy machine, truth table, FSM circuit, and then we go to state minimization. Okay, first of all, what's a Mealy machine? So Mealy machine, the different from more model is the output depends on the function of the present state and current input. Therefore, the output can change when any input change. Okay, so the keyword is the output depends on present state and current input. Compared to more machine, the output only depends on present state. Okay, so for Mealy machine, the output depends on current input and present state. Okay, and then the output can change immediately after a change at the inputs, meaning that the clock is independent. Okay, and then a Mealy machine construct in this fashion has asynchronous output. Okay, so the output for Mealy machine is asynchronous. Okay, so you can see that this is the figure for Mealy model. The difference between more model is they have input signals. Okay, and then they have state diagram for Mealy machine. Okay, we can see that they have two state, which is A and B. Okay, so the main difference between Mealy machine and more machine for this state diagram is the output, the input and output configuration. Okay, you can see that for state A, the input and output is right outside the state. Okay, we write the input first and then slash with the output. So the input, for example, this one for state A, we have input 0 and input 1. So input 0, the next state is state A and the output is 1. For input 1 from state A, input 1, next state is state B and the output will be 0. Okay, meanwhile for state B, they have input 0 and the output is 1. The next state is also B. So this state diagram will reflect to the truth table. So you can see that okay, the present state for Q node, meaning that for 00, meaning that it is represent a state A, and 11 represent the state B. Okay, for present state state A, they have two input which are 0 and 1. Okay, for 0, the next state is 0, which is A, by referring the state diagram previously. So state A, input 0, next state is 0 or A, and then the output is 1. So we put 1 here. Okay, then next is still state A, input 1. Okay, input 1, next state is 1, or we can say that this one is actually B. Okay, state B. So we write this here 1 to represent the state B. Okay, then the output is 0. Then next is state B, the input 0, output. The next state is B, which is 1, and the output will be 1. Okay, meanwhile for still state B, but you can, when you see that state diagram, from the state diagram, they have no input 1. So the next state will be don't care. Same goes to output, don't care. Okay, so we already complete the truth table for this Mealy machine, two state A and B. So for flip-flop inputs, for example, this is D flip-flop. So D flip-flop, as you know, it similar with next state. So we just copy the next state input to flip-flop input D flip-flop for and paste here. Okay. Okay, so this is the after we complete the state diagram previously and also complete the truth tables. So from truth table, uh, usually we will draw the K-map and then get the equation. So and then we can draw this. Okay. Okay. So so this circuit is not related to previous example. Okay, meaning that this example not represent this circuit. Just mention this slide just want to mention the example of Mealy circuit. Okay, you can see that from this circuit we can uh, examine that this Mealy circuit is have a little bit different between Mealy model and Moore model. Okay, as you know, the Mealy model is depends on input and present state. Okay, so where input, so for example this circuit, for this circuit this is input I. So you can see that this I is connected to output Z. Okay, and so we can say that this is a Mealy machine. Okay, same goes to this one. So we have input X. Okay, X, this is X bar that represent that contribute to the output Z. Okay, so input and output Z. So this means that this is the Mealy circuit. Okay, if you look back to more machine model or more model circuit, you can see that the input is not connected to the output. Okay, so this is how you examine uh, this circuit is for Mealy or more model. Okay, okay, and then the comparison between Moore and Mealy FSM. So this is the state diagram for Moore model and this is for Mealy model. Okay, as I mentioned before, so for Moore model, the output is usually right or located inside the state and the output will be here. Okay, for Mealy model, the input and output will located or right outside the state and we usually write like this, input slash output. Okay, so that is the main difference for state diagram between Moore model and Mealy model FSM. Okay, before we go to first example, this example is about sequence detector for Mealy model. Okay, as we already learned about sequence detector for Moore model, so this is Mealy model machine for sequence detector also. Okay, output is function of state and input. Okay, because this is a Mealy model. Okay, then specify output on transition arc between state. Okay, so this example, the sequence detector 401 and or 10. We need that when this state or this design contain 0 and then 1 or 1 and then 0, the this detector will write the output as 1. Okay. Okay, for example, this is we have three state A, B, and C. First, we look at state A, and then we have input 0 here and output 0. And then for input 0, it will go to next state B. For input 1, it will go to next state C. Okay, and then for state B, input 0 will be next state B. Input 1, it will be C. For state C, input 0 will be next state B, and input 1, the next state will be C again. Okay. So if we look at from this state A. So 0 input and then another 0. That's why the output will be 0. Okay, this 0, 0. And then when the input, for example, this one, input 0 and then input 1, the output will be 1 because it detects the 0, 1. Okay, 0, 1, so the output will be 1. Same goes to 1 and 0, the output will be 1. Okay, and then if we start from state B also, the input 0 and then next state, the next input is 1, so the output will be 1. Okay, because detect 0, 1. Okay, for 1, 0, this one 1, 0, so the output will be 1 also. And then for state C, 1, 0, the output will be 1. Okay, 1 and then another 1, the output will be 0 because this design will give output 1 if the if we detect 0, 1 or 1, 0 only. Okay, and then if we analyze from this one, this is input 1 and another 1, so that's why the output is 0. Okay, because this is 1 and 1, not detect the 0, 1 or 1, 0. Therefore, the output will be 0. So this is the correct design for this sequence detector for 1, 0, 1 and 1, 0. Okay, so after that we can draw the truth table. Okay, for reset, meaning that if reset set or 1, so the output will be 0, or meaning that this design is not function. Okay, if reset is 0, so this detector will start function. So that's why when 0, this design is not function. Okay, and when reset is 0, so this sequence detector will function. Okay, so from state A, so we have 1, 2, 3, three state for A, B, and C. So meaning that we have 2 bit. Okay, because we have 3 state. The maximum for 2 bit is 4 state. So that's why we have to use 2 bits. So for state A, we have 0 and 1 input. Okay, because input is 1 bit. So for state A, they have input 0 and input 1. For input 0, you can say that the input 0 for state A, input 0, it will give output 0. Okay, so output 0, we write here. And the next state is B, so we write B here. Okay, for input 1, A, input 1, next state is C, so we write down in C here, and output 0, so this is 0. And then for state B, input 0, so input 0, next state is B, output 0. Okay, current state state B, input 0, next state B, output 0. Okay, next state B, output 0. And then for input 1, next state C, okay, input 1, next state C, output will be 1, 1. Okay, for state C, this is input 0, next state is B, input 0, next state B, output will be 1. So we write 1 here. And for state C, input 1, this one, input state C, input 1, next state will be C again. Okay, C again. So we write C here, and output will be 0. Okay, so this is the truth table for this sequence detector Mealy model. Example 1. Okay, so this is example 2 for Mealy model. Draw a truth table and logic circuit for the state diagram below. This design should use D flip-flop. Okay, so we have how many state here? 1, 2, 3, 4. So 4 state. Okay, step by step solution. Analyze the figure and transfer input into a truth table. Okay, so and then identify the number of bits. So we have 2 power of n number of state that n is equal to